Welcome to AP Environmental Science. In this video, we are going to discuss some methods to reduce the amount of waste that is produced. Now, in order to reduce our overall waste production, we need to shift our way of thinking. The conventional thinking is that we're going to just landfill all this waste and it will go away. But we really need to shift into thinking of how can we reduce this waste to begin with so there is less that is overall going to end up in a landfill. Now the 3 R's are reduce, reuse, recycle, and that is the order in which they are preferred. Now some people would put a 4th R in there before reduce and they would say refuse. Now refuse and reduce mean basically the same thing. It's trying to look at ways we can prevent waste from even being generated in the first place. Then reuse would be after something's already made, how can we use it over and over to increase that time from when it's produced to when it would eventually end up being disposed. So this would be upcycling something. And then recycle would be when that object has reached the end of its usable life, we can break it down to its individual components and then use those raw materials to make something new. Now, recycling reduces that global demand of raw materials. However, it can be very energy intensive. And because it's energy intensive, it can cost a lot of money. So that means that people are not going to automatically start recycling things just out of the good of their heart because it's going to cost money. Also, every single time a raw material is recycled, we see a little bit of a degradation in the quality of that item. Now, there are 2 main types of recycling. We have open loop and closed loop. With open loop recycling, we are converting that original product into something that is brand new, so something that's kind of different. So we have the example on here of turning a plastic bottle into, say, a fleece jacket. So we're turning it from one thing into something else. Closed loop recycling is breaking down that item into its raw materials and then using those raw materials to make that same item again. So it's more of a circular process instead of this open process. We can also recycle e-waste, but keep in mind that e-waste contains those heavy metals, which are persistent pollutants that bioaccumulate, and if those heavy metals end up in a landfill, those can leach into that leachate, or the liquid in the landfill, and if that would get out of the landfill, that would cause some pretty severe contamination of the groundwater. So by recycling this e-waste, we can reduce those potential impacts on the environment. We can also compost some of the material that ends up in our waste stream. So things such as food scraps, paper, and yard waste can all be recycled. There are some pros and cons to this. Your pros is that this is reducing waste from going into the general waste stream, and we are producing that usable product, which is a fertilizer. But the cons are that some composting systems may produce a bit of an odor if they're not managed appropriately, and again, they could attract rodents. Now, a lot of these composting systems can look very different. They can be done on an individual household scale or scaled up to an entire community-wide effort. Now, depending on the size of the system and the amount of compost that's being produced and food scraps, etc., that are being brought in, you might have a little different system. In the small scale, you could have a barrel type system that you turn every now and then as you're adding in the food scraps to keep that aeration going on. So that makes aerobic decomposition, which is producing that good fertilizer. You also want to make sure that the moisture content stays appropriate. So oftentimes in these layered systems, you will layer some dry yard waste with that wet food waste. So it looks kind of like a lasagna. Landfills, after they've been capped, can be returned to a usable purpose. So we can restore habitat and we can use a lot of these old landfills as parks and recreation areas. So it's not all bad news in a landfill site. However, all of that waste still remains underneath in there, and we still need to monitor the groundwater and that methane gas release. We can also have these waste to energy solutions to try and get the most out of this waste that we're throwing away. Now you can take the methane from a landfill, collect it, and burn that to produce heat, or from an incineration plant, as you're burning that trash, you're creating heat, and that heat, regardless of the generation source, can be used to spin a turbine, and that turbine can spin a generator, and that generator can make electricity. Also, that heat can be used through a series of pipes to heat buildings. So we can find multiple uses for all of this waste. Now I really like this diagram on here because you can see that the exhaust gas from that incinerator is going through a few pollution control devices. So we can see a dry scrubber and a baghouse filter being used to reduce some of those pollutants. And ideally, if everything goes correct and if the waste that was brought into the incinerator did not contain anything totally crazy, ideally we would just have water vapor and carbon dioxide coming out the stack. In real life, that's not always the case. Sometimes when we're trying to mitigate this impact of landfills, things can go wrong. And an example of that would be in Love Canal in New York State. There was this neighborhood there in the Love Canal neighborhood adjacent to this waterway where people started to notice there were abnormally high incidents of cancer. And they later found out this neighborhood was constructed on top of a hazardous waste dumping site and directly adjacent to a river that had a lot of hazardous waste. Now in the 1970s, this is when people started noticing all of these issues, and the residents in that neighborhood noticed a chemical odor in their homes. After doing a whole bunch of neighborhood campaigning and getting the media involved to bring national attention to this issue, eventually this area was designated as a Superfund site, which allowed the federal government to come in. They purchased many of these homes to help evacuate these people out of this dangerous situation. And by 1994, most of this waste had been cleaned up, and this was no longer a site on the national priorities list of areas that have experienced hazardous waste contamination. Let's talk a little bit more about that Superfund. So the Comprehensive Environmental Response, Compensation, and Liability Act, better known as CERCLA or the Superfund Act. You need to know this act, so I suggest pausing the video and writing this all down. This is essentially making a tax on chemical and petroleum industries, and that money from that special tax is going into a fund so that way if for some reason a company is not able to deal with their hazardous waste because they've gotten bankrupt or somehow just disappeared, the federal government now has money to be able to come in and clean up that site. But this act also created this liability for the people that are responsible. So now the federal government can go after those chemical companies and the people that were involved in making these decisions and hold them accountable for dumping this hazardous waste. Another act that you need to know is the Resource Conservation and Recovery Act, or the RCRA or RCRA. This is looking at waste from cradle to grave. So cradle meaning when we're extracting those raw materials, and grave meaning the landfill. So this is trying to look at hazardous waste holistically and setting a framework for how we manage hazardous waste and non-hazardous waste. Part of RCRA is this life cycle analysis and integrated waste management. We're considering all of the materials and energies throughout the entire lifetime of a product. And I encourage you to take a moment and think about if you can trace back the original components of, say, a mechanical pencil all the way back to its original components, and think about what would happen at the end. So we need to consider source reduction of the waste for where we are making it, what materials are involved in the creation process, in the extraction process, the manufacturing, and the transportation. Then once that product is on the store shelves, we have to think about the packaging that it is in and how that particular product is used and if it's designed to be reused and replenished. So with the mechanical pencil, you may be able to replace the eraser or replace the lead in there so you can get a longer use out of the product. But then finally, when the pencil inevitably breaks in half and you're not able to use it anymore as a functional product, what happens afterwards? Is it sent to a landfill or is it sent to a recycling facility? Another way to look at it is this diagram here. We have our resources, raw material, energy, and water that go into the extraction, processing, design, manufacture, distribution, use, repair, and disposal. And then we have the waste produced from each of those steps. So trying to think of the overall life impact of each individual product that we use in our lives. Now, in summary, you should be able to describe some changes to the current practices that could reduce the amount of generated waste and be able to think of some of the benefits and drawbacks of each approach. Some of the things we discussed were recycling, composting, landfill mitigation, the legislation of CERCLA and RCRA, and the idea of a life cycle analysis. Please leave me your questions here at the end, and I hope that as you watch this video, you were able to learn something.